Welcome to Tuesday Lunch and Learn. I'm James Shore. Every week we look at an interesting software development skill or technique, come up with a challenge related to that technique, and then solve it live on stream. And this week, it's testing without mocks. If you'd like to follow along with today's code, you can download it from GitHub, github.com/jamesshore/livestream. Check out this tag here, 2020-05-26 to follow along. Also, your questions and comments are very welcome. I'll take some as they go. Just put them in the chat, and we'll also have time at the end for additional questions. This is a big topic. I got a lot planned for today, so let's just go ahead and dive right in. So the topic is testing without mocks. And you might be wondering, why would we want to do that? If you were watching the episode last week, and you can find all previous episodes down here, jamesshore.com/blog/lunchandlearn. If you saw it last week, then you saw us talk about how mocks and spies and other sorts of test doubles are a tool for testing the interactions of your code with other objects in your system or other parts of your system. And it's also a way of isolating your code from its dependencies so you can test it cleanly. That's really valuable. Why would anybody want to not do that? Well, mocks and spies do have a downside, which is that they're solitary tests. If you test a system with nothing but mocks, you end up with gaps because a mock-based test, a solitary test, will check that A is working correctly, for example. And it will check that B is working correctly, and it will check that C is working correctly. But it will not check that B works the way that A expects. And it won't check that C works the way that B expects. So you end up with these little gaps where if we can test that A is using B, but we can't test that A is using B correctly. And when it doesn't use B correctly, then we have a bug. So what we do to cover that is we create integration tests, tests to cover all the various parts of the system. But those tests are slow. They're difficult to maintain. They are duplicated effort because now we're testing the same code over again in a different way. It would be nice if we had the ability to write our unit tests so that they did not require this duplicated effort of requiring integration tests, so that we didn't have the gaps between the units in our system. And that is today's challenge. We're going to be talking about how to do that. We're going to be using our Rote 13 application that we've developed in previous episodes. And again, you can find the archive at jamesshore.com/blog/lunchandlearn. This Rote 13 application is a simple little command line utility where you type in some string and it gives you back the Rote 13 encoded version of that. Rote 13 is the little spoiler hiding mechanism you see on the internet. There are three major pieces of this application. There's app.js, which is sort of the top level traffic cop. It reads in from the command line, runs Rote 13, writes back out to the command line. Rote 13.js is the logic of the application, and command-line.js is an infrastructure wrapper. It wraps up the underlying node process object and gives us the ability to do what we want with it. This is thoroughly tested with focused integration tests on our command line class and mock-based test on app.js. But what isn't tested is that app.js uses command-line.js correctly. So today's challenge is that we're going to fill the gap without using integration tests. We want to test that app.js uses command-line.js correctly, but we don't want any integration tests. So how do we do that? I'm going to let you all ruminate on that for a moment. This stream is made possible by people who hire me to do training and coaching for their teams. Typically, I specialize in working with low bureaucracy organizations, companies that have the ability to have a lot of business agility, but maybe they don't have the technical capacity yet to support the level of business agility that they want. So they bring me in to do test-driven development training, other sorts of agile engineering training for anything from a single team all the way up to collection of mini teams, dozens of teams. It is thanks to these above average folks that I'm able to do this for you today, have the free time to do this sort of stream for you. Otherwise, I'd have to get a real job and nobody wants that. So if you would like to support this stream yourself or become one of these above average folks, go ahead and send me an email, jshore@jamesshore.com. I'd be happy to set up a consultation for you, free consultation, talk about what's happening in your company, what's going on with your teams, and how we could possibly work together. So love to hear from you. And with that said, let's get back to the challenge. We want to fill this gap between app.js and command-line.js. How can we do that? There are two basic approaches here. Now, the whole approach for the whole solution is documented on my blog, jamesshore.com/blog/testing without mocks. And if you Google testing without mocks, you'll probably find it. But if you don't, try Googling James Shore testing without mocks. It should show right up. There's a whole bunch of patterns in this article, but the two primary ones, the ones that we're going to cover today, are overlapping sociable tests and nullable infrastructure. And let's take those in turn. Overlapping sociable tests, like solitary tests, this term was coined by Jay Fields, and I heard of it thanks to Martin Fowler. What you see in a mock-based test, in an isolated test, the dependencies of an object are considered to be behavior that needs to be tested to see if it's working correctly. In a sociable test, or at least the sociable tests the way I use them, the dependencies of the object are not behavior to be tested, they are implementation to be encapsulated. So when we test A, part of confirming that A works is checking that B was called the way it should have been. But A calls the real B, which calls the real C. So when we test A, we're actually running B. And as a result, we're able to test that A uses B correctly. And by doing this, we create this nice linked chain of tests that allows us to confirm that the whole thing works without needing separate integration tests. And this may seem hard to believe, but I've been doing this for years now, and it really does work. And I've been doing it on real projects, not just toy examples. So yeah, you get this fine mesh of overlapping links in a chain that test that everything worked together correctly. In our Road 13 application, we're going to do the same thing. We're going to test app.js. We're going to test it sociably. We're going to test that app.js really calls command-line.js. It's already testing that it's really calling road13.js. Command-line.js already has tests that it really works with a real process. And as a result, we're going to have coverage of the whole system, except for run.js, which we're ignoring for today's exercise. We're going to have tests of the whole system without having integration tests. Now, if you're going to do this, you've got a little problem, which is that if you're doing sociable tests and you're actually running real code all the way through the system, eventually you're going to get to infrastructure that you don't want to run. For example, in our app.js, we don't want our tests to actually write stuff to the command line. If we were doing microservices, we wouldn't want to actually call a microservice. How do we deal with that? That's where the second pattern comes in, and that second pattern is nullable infrastructure. Nullable infrastructure is real production code that can be turned off. It can be nulled. It has several characteristics. First off, as I said, it's real production code that can be disabled. It has the identical semantics as real production code because it is real production code. It's exactly the same as the real production code. All the same code paths run in the null state or the real state. The only difference is the part right where we talk to the outside world, that's turned off, but everything else is kept as real as possible. Because we're not actually talking to the outside world, and also when you're dealing with infrastructure, sometimes it's sort of write only, we write this production code so that it can track state as needed and it can be configured as needed for the purposes of our tests. Now, I'll have to admit, some people find this idea of writing production code that's only used by our tests, they find that really ugly and they don't like it. And I would say that as well, all engineering is trade-offs. And there's some uglinesses that you see with mock objects, and the biggest one, I think, is this need to have duplicated tests to test that everything integrates. And if you're going to use nullable infrastructure, there's some ugliness with that. There is nothing, no silver bullet anywhere in software engineering. So your choice, and it really is your choice, I'm not going to try to tell you there's a right answer here. Your choice is which ugliness is better for you in your situation. And the answer may be different or will be different depending on your context. I've been trying this for quite a while, and I have to say that I find that the ugliness of the nullable infrastructure is less than the ugliness of doing mocks for most of the stuff I do. But whether or not that's true for you, it's totally your call. And I am absolutely fine if you don't like this idea of nullable infrastructure, of real production code that can be turned off. Now, one of the ways that we make this nullable infrastructure work cleanly is with embedded stubs. And I'm going to show you what that looks like when we get to the example. But embedded stubs are a way of turning off the external system while keeping the rest of our code as real as possible. And it's actually a pretty clean approach. But again, there is some ugliness to it, just like with everything. And whether that ugliness is worth it is going to be a call for you to make for yourself. Okay, so let's get into the example. If you'd like to follow along, again, you can do that by going to github.com/jamesshore/livestream. Check out the tag 2020-05-26. At the end of the stream, I'll be checking in the finished results with the tag 2020-05-26-end. If you'd like to follow along, you'll need to have node.js installed because this example is written in JavaScript. This is not really a JavaScript stream. I just use that as an example, but everything I'm going to show you here does work in other languages as well. Once you have node.js installed, you can build, lint, and test the code by running build.sh or just build on Windows. That will lint all the code and run all the tests. And then if you want to run a quick build that only runs the things that have changed, you can run build quick. If you run watch, the watch script, that will automatically run the build when the tests change, and you'll also get a nice little sound like that that will tell you if the test succeeded or failed. Now let me show you what this looks like when we run it. It is just a simple little command line application. We can run on the command line, run hello, run.sh on Mac and Unix, just run on Windows, and it will give us the Rote 13 version of that back out. Now let me demonstrate the issue that we have. Right now, our application is thoroughly tested with mocks. It's a very simple application, so thorough testing is not a lot of tests, which is nice for an example. And you can see here that our tests assert that we're going to create a command line mock. We're going to tell it that when we ask for the command line arguments, we're going to return the input, we're going to run the application, and then we're going to verify that we write the output. So far, so good. It's a good test. Down in our application infrastructure, we have an infrastructure wrapper for the command line and tests around that. Now let's say that we realize, some point down the road, we realize that our command line wrapper, which has a write output function, that writes the output with a carriage return at the end, we realize that that was not really a great idea. It's not very flexible. We don't necessarily want to put a carriage return at the end of every single piece of output. So we change that, and we do it test-driven. We're going to come into here and we're going to say the behavior of command lines should no longer be to have a carriage return at the end. And we'll run those tests, and they fail. We expected it to have a carriage, it's getting a carriage return, but we expect it to not have one. So that's great. We'll just come in here and we'll fix that like that, and check, make sure that works. Test pass, we're golden, right? Everything's good, we're done, let's check it and ship it. Except if we run this for real, we now see that we've introduced a bug. We don't have the carriage return at the end in our app, in our real application. That is one of those little niggly UI bugs that you tend to see in software. And our test did not catch it because of that gap between our app and our command line. So this is what we're going to fix. This is what sociable tests and nullable infrastructure give us, is they are going to allow us to make the change you just saw without breaking the code. Let me go ahead and put this back. And let's get to it. What we're going to be doing is we're going to want to write sociable tests for our application. What that means is that rather than using mocks, we're going to use the real command line, but we're going to use a null version of the command line. In order to do that, of course, we need to make a null version of our command line. So let's do that. I'm going to describe a new thing. I'm going to call it nullability. And we're going to say that a null version of our command line code is just like the real thing, except that it doesn't talk to the outside world. So we're going to say it doesn't write output to command line. So we're going to need to, now in our command line tests, because we're testing it for real, we have to spawn a separate process in order to run our test. So that's what we're going to do here. We're going to say run a new module, and we'll call that module command line test null output runner. And again, if you're curious about how and why we do this, check out the Lunch and Learn archive. It's the episode called Application Infrastructure. It was a couple of weeks ago. And then we're going to run the test, and then we're going to assert that we get nothing out on standard out. So this is not going to work because, well, I forgot the async. But in addition to that, it's not going to work because we don't have the module. And that's what we're seeing. Module doesn't exist. So now I'll go ahead and create a module here. And we'll call that command line test null output runner. And this will work now because, well, by default, it doesn't write anything out, which is good, I guess. Now we'll require command line. And we'll call create null. We're going to get the null version of this command line. This is going to fail because we don't have a create null yet. And that's exactly what happened. Create null is not a function. So let's go ahead and add one. And to start with, I'm just going to have this return the real thing. Okay, so we've got our test still working. Now let's write the output, and this output should never be seen. In fact, I think I'll say that. This output should never be seen. Because the null, well, should turn off the output to the command line. But it is actually writing it to the command line, and so this is the problem. This is what we need to fix. So how do we do this? Well, remember, we want this to be as real as possible. We could write this with a little bit of spaghetti code, and I have done this in the past. We could say that the command line is null. Let me just show you what that looks like. So we'll pass in an is null parameter, and then down here we can say, if this is null, return false. Or not return false, just return. Don't do anything. And I would have expected, I actually would have expected this to fail. So why did that, or that to pass? So why did that not pass? Oh, this dot is null equals is null. Dumb mistake. Thanks for the question, JitterTed. I'll get to you in just a moment. So this will work. This will create the null command line, but it's not very good code. But one thing I want you to notice here is the way we choose to implement this is completely encapsulated. Nobody from the outside knows how the null command line is implemented. They just know that if you call command line.create null, you get a command line that does not actually write to the command line, which is nice. Now, JitterTed asks, is this feature flag-like? And I would say no. It's not really feature flag-like at all, and you'll see how it's different as we get on a little bit further. This does kind of look like a feature flag because we're using the if statement, but actually this isn't my preferred way of doing the nullable infrastructure. Now, you can implement nullable infrastructure however you like. It's completely encapsulated. But in my experience with a more complex piece of infrastructure, this gets ugly. It turns into spaghetti code. Also, we want our nullable infrastructure to run the same paths, the same code paths that our regular happy path infrastructure uses. We want it to be as real as possible. So to do this, what I use is an embedded stub. An embedded stub is a test double that is entirely encapsulated inside our nullable infrastructure. Nobody on the outside knows or cares that we have a test double. And the way it works is what we're going to do is we're going to inject our process object into our constructor from these factory methods. Or if you're using another language, you might have a private constructor or some other way of doing it. But the important thing here is we don't expose the fact of the injection. So what I'm going to do is I'm going to pass in the process object here, and I'm going to pass it in here for now. We'll call that proc. Say this.process equals proc. So now we've injected the third-party library. In this case, node.js is global process object. You'll notice here that unlike in mocks where you never double third-party code, with an embedded stub, you're only ever doubling the third-party code. So now that we've injected this process, we can use it down here in our write output. And that should still work. And it does. And this code's very thoroughly tested, so I trust that that works. Now that we have the ability to control which process is being used, we can make a null version of this process for the use of this create null. Again, it is not exposed outside of this class. So I make a new null process class like this. In order for null process to work, now one of the important things about these embedded stubs is we're not going to stub out everything. Process is this huge node.js global object that's done for all sorts of things related to the process. But we don't care about that. The only thing we care about right now is standard out.write. And so that's all we're going to implement that. And because that's the way this works, it actually turns out to be really easy to write these embedded stubs because they're actually usually very, very small. We're going to write standard out. So this gives us the ability to get the standard out back. And then we'll have that return an object with a write function on it that does nothing. And that is it. That is all we need to do to stub out write output. Now we're not using this yet, so it's not going to do anything. But now here in create null, I can say new null process. Pass that through instead of the real thing. And if I've done that, then now I don't need this is null. And the code still works. We don't need this. We don't need this. We don't need that. We just implement this with an embedded stub. So all of our production code is the same for both the create and the create null paths. They're absolutely identical. The only difference is that when we have a null, we're using a null version of our process. And this makes the nullable infrastructure pretty clean. Jitter Ted asks, so this is more like null object-like. Absolutely, that was the inspiration for this. Now, of course, in a null object, what you tend to have is a single interface. It's more like a standard mock in that you have an interface and you're passing in either the real thing or you're instantiating in a completely separate class, which is the null thing. Here, the distinction between the null version and the real thing is hidden inside of command line. And the fact that we're using the null object is hidden inside here as well. Uncle Scientist asks, do you have to change the args function too? Yeah, and we're going to get to that in just a moment. But first, we have the ability to null out our output to the command line. But if we're going to be testing that this code writes the command line, we now have to have some way of observing that this has happened. Because we're not using a mock, there's no way to spy on this. We have to actually ask. And this is another thing that you're going to see with nullable infrastructure is you're going to need to introduce state so that you can query the things that you want to query. But that state is not it is like everything else, it's tested production code. So we're going to write a new method, and we're going to make that just part of the normal behavior of this code. It remembers the last output. Now I could implement this with one of these modules, but those are actually really slow and painful. I've got this nice create null. Let's use it. So I'll make a command line dot create null. And let's say that, and we'll write out to that command line, my last output. And we'll say that command line dot get last output gives us my last output. And this is going to fail for several reasons. We don't have a get last output. Hey, JitterTed, I'll answer that question just in a moment. Thanks for the question. Command line's not defined, so we'll have to bring that in. Okay, now it's complaining that get last output doesn't exist. So we'll write this just as normal production code. And now that we've added it, it's going to complain that it was undefined, not my last output. So let's take our output, put it in a variable, and then save it off. Then here we can return it. And that should have made the test pass, but I just realized we expected my last output with no carriage return, but there is actually a carriage return on it. And that was a bug in our test. So let's go ahead and fix our test there. And now it should pass. And there we go. So what you'll notice here is that get last output is just normal production code. It's JitterTed asks, so is this a production spy? Not in the technical sense of the word. A spy is a type of test double that gives you access to how your code is called. This is not actually a test double. This is just an accessor. It gives us insight into what's going on in our code. It's only used by our tests, and again, some people find that ugly, but it's just a way of doing state-based testing. Now, there's another piece of behavior that we haven't documented yet that I want to document, which is that I want to say that the last output is undefined when nothing has been written. So we'll create a null, and we'll just assert that command line dot get last output is undefined. And this should be the behavior we're getting already. And if I wanted to spend more time on it, I might make it default to null or something like that. But I think this is good enough. JitterTed says, yeah, by production, I meant that it's spy-like, but the state is held in the production code instead of being a separate test-only class. Yeah, and that's exactly what this is. I wouldn't call that a spy because that has implications. It's just sort of classic state-based testing. Jirland says, what about creating test command line that stubs out some functions of command line? Well, you could do that, but then you wouldn't have nullable infrastructure. Then you'd have just a test double. The value of doing this is that this is real production code. It has all the same behavior as real production code. The only way to get the benefit of overlapping sociable tests is if we actually call real production code. Otherwise, if we're calling a test double, like a stub or a test command line, then it's not going to have the same behavior as the real production code, and our tests won't fail when the behavior in our production code changes, but the test code doesn't. So that's how so now we have the ability to null out our output, and we have the ability to see what was written to the output. We're not quite done yet. We also need to deal with the arguments, as Uncle Scientist mentioned. So what I want to say is that by default, it has no arguments. Let's say it defaults to no arguments. So I'm going to make a null command line. and I'm going to assert that the arguments for this null command line is empty. Hey, Franz Mador, I'll answer your question in just a second. Thanks for the question. Except that that's not how this actually works right now. Right now, it is looking at the real command line arguments, and the real command line arguments are quick from our watch quick function. So what we need to do is we need to have our args also use our embedded stub, and we need to have our embedded stub implement argv, because that's process.argv. And we'll just have it return an empty array. And we'll need to put a dot in here. And there we go. Franz Amador says, still not clear why this is better than passing in standard out, which might instead be a spy. Well, again, this is how the code's already implemented. It's implemented with a test double, which is a spy. But that code doesn't fail when we change the behavior of our command line. Now, maybe you're wondering why not pass in standard out to command line? Why not have just expose new command line and then pass in, process? And that's because you can do that, but I don't think it makes it any cleaner. I think one of the values of object-oriented programming is information hiding. It's encapsulation. The details of how command line is implemented is completely opaque to the callers. We want to have this embedded stub to be alongside this code because it is explicitly written only for this code. So it needs to be encapsulated with this code. If we expose this to others, they're not going to know how to use it correctly. So all we want the callers to know is that if you call create null, you get the behavior you want. Yeah, you could take null process and put it in a separate class and pass it in, but you're going to create more complexity without any benefit. At least that's my take on it. But I would love for you all to go ahead and take these ideas, experiment with them, come up with better designs. I do not have a monopoly on good designs, far from it. So now that we have the ability to default this to no arguments, we are also going to need, in our test, we're going to be able to define what those arguments are. So let's add another test and say that it allows arguments to be configured. And when I'm configuring my nulls, and we'll make this a parameter to our create null, when I'm configuring my nulls, I like to use optional named arguments because there's often going to be multiple possible configured responses, and you're not going to care about all of them in every case. So I'll default some to some default value and allow us to just name what we want. So I'm going to say that we've got an argument 1 and 2, and we should expect that our command line args is equal to 1 and 2. But of course it's not. It's an empty array. So we're going to see a failure. So now what we need to do is configure this. And what we'll do is we'll take the arguments here, default it to an empty array, make it so you don't have to pass in anything at all, and we'll pass those arguments through to our null process. And our null process will save those off, and then we'll return them here. But the real behavior of argv is that actually the first two parameters are node and the script, and then our arguments. So this is how I have to implement it. And there we go. Now, if these values are ever exposed, that means that something has gone wrong somewhere. To make that more obvious, I like to do something like this. I like to make it really explicit that these are not real things, that these have been created by our null. And that is our nullable infrastructure. Now we have the ability to create a null version of our command line that works exactly the same as our command line, but can be turned off and configured. And it is production code, so it has production tests. Most of the time, I'll admit, most of the time this nullable code is only used by your tests. But because it is production grade, it is possible, it's conceivable that you would use this in your production code. And I have done that, not often, but it does happen from time to time. Let's go ahead and check this in. We made our command line nullable. Okay, let's see what this looks like when we actually use it. This might seem like a lot of work, and I think that is one of the downsides of this testing without mocks strategy, is that it is more work to create the nullable command line than it is to use a mocking framework. On the plus side of it, though, is that you generally only do it once. Like I've been experimenting with this for years. I use it in real production code, and I've got a production app that is 8 years old at this point. And I never, ever go back to the null code. Once you write it, it's done. It's out of sight, out of mind. You actually end up, because it's already written and available, you end up, I think, messing around with test doubles less than you do with mocks. Because, well, it's written. It's done. So let's go to our app. Here's our app tests. We're going to replace these mock-based tests with the nullable infrastructure. Let me just walk you through what's happening here. This test is checking our main line of code. We read in from the command line, which happens here. We transform it, and we write back out. And you can see that here. First, we set up that our input is my input. Our output is whatever happens when we call the route 13 thing. We set up a mock command line. We inject it into our application. We say that the command line is going to return our input. We run the app, and then we check that we got the correct output in our output. Jitter Ted says, my experience is the same with respect to test doubles. Rarely go back and change them after stuff is built. That's absolutely true. Dota Attitude, thanks for joining us. So now what we're going to do is we're going to change this test from using mocks to using the nullable infrastructure. So we're going to have the same input and expected output. Instead of making a mock version of our command line, we're going to make a null version. And we're going to pass in the arguments of input. That's going to work. We're not doing anything with it yet. We'll create the app. Hey, Jerlyn, got your question. I'll get to that in just a moment. Thanks for asking. We'll create that and inject it just like with mocks. We'll run the app, and then we'll assert, just with a normal assert statement, that the last output from command line was our expected output. And that didn't work because we're actually getting a carriage return on the end. So let's go ahead and add that in as well. That is the behavior we want. And there we go. That is what a nullable infrastructure version looks like. Jerlyn says, so command line is basically adapter of process. In your tests, you don't want to run the actual process. You instead use the null interface. Yeah, Jerlyn, that's absolutely correct. Command line is a wrapper or adapter around the underlying infrastructure. And again, we talked about this in the application infrastructure episode a couple of weeks ago. I find that it's just generally a good idea to wrap up infrastructure, regardless of whether you're using mocks or nullable infrastructure. And then in command line, we use the null process rather than the real process so that we can null it out. Charlie Pancakes asks, if you're calling anything stateful, then how would nulling them work when the expected response might need to be different per call? That is a great question, Charlie, and let me get to that after we've gone through the entire exercise because it's a little more complicated. Jitter Ted was talking about the wrapping, says that he was doing that kind of wrapping on his stream yesterday with wrapping the HTML canvas into a surface. Yeah, it's really common to do infrastructure wrappers. It's really good, just good design. Now let's go ahead and continue this through. I'm going to go ahead and just migrate the rest of these over. So here we'll create a command line with no parameters. We'll pass it into app, run the app, and then assert that the last output is this. But again, it's got to have a carriage return at the end because we're checking what the actual output was, not just that a method call was made. And then similarly here. And that is all of our tests now converted to use a nullable infrastructure rather than mocks. And you'll notice that it's very similar to using mocks, except I find that this is a little bit more readable. As we talked about last week, there's always things you can do to make your mock-based tests more readable in terms of using abstractions. But I find that this reads pretty cleanly without additional abstractions. Once upon a time, we had a command line that took my input. We created an app using that command line. We ran the app, and we saw that on the command line, the output was the output we expected. Nice, clean, clear test. And so as a result, because it is pretty clean and clear, I find that I'm not doing a lot of abstraction around setup like I do with mocks. Franz Amador says, okay, I think I'm getting this better. I think calling it nullable infrastructure wrappers would have helped me get it sooner for what it's worth. Thanks. That's good feedback. Yeah, these are definitely, when I say nullable infrastructure, I'm talking about the infrastructure wrappers. So maybe that's a change in the language I'll start using from now on. So that is how this works. Let me go ahead and check this in. We're not quite done yet. I'm going to say that we've converted our app tests from mocks to nullable infrastructure wrappers. Actually, let's say use nullable command line. And let's see, we don't need this anymore, do we? Okay, so now we're at the same point that we were when we started, except now we're using nullable infrastructure wrappers instead of mocks. Let's repeat that test I showed you at the beginning. If we run our application right now, it gives us this. But we're going to decide that our command line, thanks, Pellet. We're gonna change the behavior of our command line. We realize that adding a carriage return to the end of every write output wasn't a good idea. So we do this test driven. We come into our test, we say when we write the output, there's no carriage return. And of course, there's gonna be no carriage return when we get the last output. Run that test and it will say, hey, you forgot to change, or you need to change your command line. We say, no problem. We'll do that there, and let's even inline this. And remember, when we did this with the mock-based tests, the mock said, we're good. We're calling command line with the methods we want. Behavior is correct, but of course it wasn't. But now, all of our application tests have just failed. And that's because we've just changed the behavior. And this is what makes the, I think, slight ugliness, or you might think it's a lot of ugliness, however much ugliness this is for using the null process and the nullable infrastructure wrapper, this is what makes it worth it. Because now we have the benefits of the integration tests without the costs. We don't have the speed hit, we don't have the complexity, we don't have to write our test twice. We just write our application tests per normal, and they detect integration errors. So to fix this, well, we're going to need to add a command line, or a carriage return here. And now we have 2 test failures and a carriage return here, and 1 test failure and a carriage return here. And there we go. I want to show you what these look side by side. Hey, Dota, thanks for the question. I'll get to that in just a moment. What I have here is a comparison of the various ways that we can test side by side. So we have the nullable infrastructure test, spy-based test using test double, a mock-based test using sign-on, and then an integration test using the run module, using forking out to a process. One thing that surprised me when I built this, just yesterday I built this, and I timed it because I was curious, what's the speed difference between using nullable infrastructure and the other forms of tests? And I was surprised to see that it's multiple orders of magnitude different. You can run, using nullable infrastructure, you can run 1 million tests per second. That is not a joke. 1 million tests per second is the actual speed of this test. Using test double, it's 2 orders of magnitude slower. It's 2,326 tests per second. Sign-on is similar. It's 3,666 tests per second. And of course, the end-to-end integration tests are really slow, 22 tests per second. So this is what they look like. Let me go ahead and put them side by side on screen here for you. Nullable infrastructure versus the mock approach. Very similar, but again, I do find that the nullable infrastructure code is a bit easier to read because it's not talking about the internal implementation details of my code. It's just talking about the externally visible behavior. We create the command line with certain arguments, and we expect certain output for the command line, versus we expect this method to return this, and we expect this method to be called with that. It's a fairly subtle difference, and it can be worked around with wrappers or with wrapping up with abstractions, but I do find it nicer to read. But the important thing again here is that with nullable infrastructure, you can have overlapping sociable tests, so you don't need integration tests. I see some comments on the chat. I'm going to take questions in just a moment. I want to give you a moment to look at this, and I have a couple of announcements before I take the final questions for today. First off, our next stream is going to be next Tuesday at noon Pacific, same as this time, and we're going to be looking at this idea of nullable infrastructure wrappers in more detail. We're going to go from less of a toy problem and start building out an actual microservice using a nullable infrastructure wrapper. So that should be really interesting. If you're looking at sort of digging your teeth into this in more detail, come to next Tuesday's session. And then before that, on Friday, Coding Challenge Friday, we're going to have a 2-hour stream from 11 a.m. Pacific to 1 p.m. Pacific. So that starts an hour earlier than this one. And it's a more casual stream, good opportunity for conversation and chat. We've had some great design discussions on that stream in the past. And we're going to be applying this nullable infrastructure wrapper idea to our existing cribbage application, which is also kind of a toy application, but it's more sophisticated, got a little more real than this Route 13 app is. So don't miss that. 11 a.m. Pacific on Friday, and then of course our next Lunch and Learn, which is sort of my main thing, Tuesday at noon Pacific. Okay, let's take some questions here. Oh, and I did want to also remind you that if you liked what you saw here today, and you'd like to have training or consulting around this idea of using nullable infrastructure wrappers, I'm very happy to do that. That is how I make my living, so I'd love for you to give me a call. That's done in your language, with your libraries and frameworks, and even your actual code base. So and at your pace. So it's a great way to dig into this and figure out how to really put it into practice on your code. If you'd like to try that, jshore@jamesshore.com is how you can contact me. Happy to set up a free consultation. So let's take a look at these questions. Just taking it in order. Dota Attitude asks, is half a second slow for tests to run? Half a second's great. If I can have feedback within a second, I am super happy. But even in a relatively small application, you'll have 1,000 tests. And so you need those tests to run fast. If we're using integration tests everywhere and they're taking 1/10 of a second each or 1/20th of a second each, that is going to add up really quickly. As soon as you get more than a second to feedback in your build, you'll notice here that we're getting feedback in about a second or two. That works great. Once you get to 2 or 3 seconds, it starts becoming noticeable. Once you get to 5 seconds, it becomes very noticeable. And anything more than 10 seconds for your feedback is just too slow, I think, for effective test-driven development. There's too much friction. It's just not fun to work that way. So I want my tests to be really, really fast. Jitter Ted says, I assume the speed would be the same as nullable infrastructure wrappers if you hand wrote the spy instead of using testable. Yeah, I think that's true. The main speed problem, and I've seen this in every language, the main speed problem with mocks is actually the mocking libraries because they're doing all this reflection and introspection and so forth, and they're slow. But hand building the mocks and spies for each test, the way you do with a framework is not really sustainable. If you do a hand-built mock that you just use over and over, it actually ends up looking a lot like nullable infrastructure. It's about the same amount of effort as nullable infrastructure. So I would just use nullable infrastructure because that gives you better quality results. Now you have the verification that the calls are working correctly. Jerlin says, I want to say thank you for your Java Let's Code series. Basically kickstarted my career 7 or 8 years ago. I learned Java and TDD from you. Hey, thanks for saying that. That's really kind of you to say. Yeah, a lot of people have enjoyed that Let's Play Test-Driven Development series. If you haven't heard, if you're watching this and haven't heard of it, it's quite old at this point, but you can find it on my website, jamesshore.com. Look under the projects or something like that, or just Google Let's Play TDD. And if you're interested in a similar idea, but for JavaScript, that's also fairly old, but it's newer. You can go to letscodejavascript.com. That is subscription based, but goes into a lot of depth about test driving JavaScript code. And also, actually, where a lot of the ideas that I'm sharing with you today about nullable infrastructure wrappers, a lot of those ideas were developed live on that screencast. Franz Amador asks, I'm wondering how this would work in statically typed languages. That is a great question. I meant to bring it up. It works very similar to the way that it works here, except that because it's statically typed, doing the embedded stub is a little bit uglier. If there's no interface for you to piggyback on, some languages use interfaces everywhere, some don't. But the net result is if there's no interface for you to piggyback on, you have to make a very tiny wrapper of the third-party code that you can then make an interface for and stub out or call the real thing. But one of the advantages of using this nullable infrastructure approach is that, you know how when you're using mocks, in a statically typed language, you have to have an interface for every single thing that you're mocking? Well, since you're not mocking everything, all that noise from all those useless interfaces goes away, except in those cases where you're actually dealing with something that needs an interface, actually has two different production implementations. And that's something I quite like about doing this in statically typed languages. Jitter Ted says that less than 3 seconds per test run is my goal for TDD. Absolutely. And in my real production code, I've got about 1,000 tests, and it takes 9 seconds to run the entire clean build, running all the tests, all the integration tests, all the smoke tests. Takes 9 seconds, and then I use the quick build that I used here. It's actually the same build script. I use that to run subsets, but I can chunk it down into quite large subsets because the tests are so fast. Pellet asks, do you have any techniques that you use for dealing with weird behavior you can find in real implementation, such as strange network exceptions that are rare? Or is that's something that once you get bit with, then you make tests to cover it? That's a really good question, Pellet. I think we're going to get into that next week when we're going to be doing testing we're going to build a microservice using these ideas. But I try to think of those. Test-driven development does help me think of them. I don't think of all of them. Sometimes I just get bit. But doing test-driven development of your infrastructure does sort of force you to think through all those details more carefully. And I find that I don't get as bit as often as I would otherwise. Dota Attitude asks, what about PHP? I think it would be very similar to JavaScript, although I've never programmed in PHP, so I actually don't know the answer to that. Yevon B asks, what about nulling database calls? That is a really good question, and the answer is actually the same as when we did nullable infrastructure wrappers 2 weeks ago. And again, you can find that jamesshore.com/blog/lunchandlearn is the archive. That was about creating these infrastructure wrappers. And the question came up then, can you use infrastructure wrappers for databases? And the answer is yes and no. if you can wrap if you're not using a heavyweight ORM, then you can write your own wrapper around your database. Like if you're using a sort of a lightweight SQL library, you will make your own infrastructure wrappers for your database calls. And those can be nulled. Anytime you use an infrastructure wrapper, you can make a nullable version of that infrastructure. If you are using a ORM tool, you're stuck with whatever it provides you. It's probably not something you can wrap. You probably can't use nullable infrastructure. So that's the trade-off you make when you decide to use a heavyweight framework, ORM framework, is it will make some things easier, but it might make testing harder, and that's a choice that you'll have to make. You'll probably have to end up using a dependency injection framework rather than the simple clean dependency injection I've been using. And I don't care to do that, so I don't tend to use those heavyweight ORMs. Jitter Ted says about PHP that it has interfaces similar to Java. Okay, that looks like the end of the questions, which is also really good timing because it's just about 1 p.m. Here in Pacific time zone. That is our stream for today, testing without mocks using overlapping sociable tests and nullable infrastructure wrappers. I hope you enjoyed this. Again, if you did, and you'd like to have me do some of this work with you, with your team, give me an email, jshore@jamesshore.com. You can find the code, github.com/jamesshore/livestream. I'll be checking this in 2020-05-26-end in just a few moments. And again, next week's stream is going to be about microservice. So we're going to build a microservice using these ideas. And on Friday, Casual Coding Friday, we're going to be digging into nullable infrastructure wrappers in a bit more detail. So I hope to see you then, 11 a.m. Pacific. Thanks, everybody. Really appreciate coming along, and have a good evening or afternoon. I'll see you next time.